The largest building blocks in the universe are galaxies. Galaxies are groupings of anywhere from billions to trillions of stars, all that are gravitationally bound to each other. The galaxy we live in is named the Milky Way. This name comes from Greek mythology. Galaxies were first identified in the 17th century by French astronomer Charles Messier. Although he was the first to observe these objects, he did not understand what they are. In fact, the understanding of what galaxies actually are didn't come until the 1920s. Originally, astronomers thought galaxies were objects that resided in the Milky Way galaxy. Because of the more rudimentary equipment of the time, galaxies looked like fuzzy spots in the sky. This led to the assumption that they were just nebula. This incorrect assumption was believed until 1924, when Edwin Hubble discovered that the Andromeda Nebula was actually an entirely different galaxy separate from our own. This fundamentally changed our understanding of the universe. The scale of the universe grew many orders of magnitude larger. We went from believing that there is one galaxy with billions of stars to an understanding that there are trillions of galaxies with billions or even trillions of their own stars. With this new understanding of the universe and more advanced equipment, astronomers set out to discover more galaxies. Galaxies come in many shapes and sizes, but as unique as they all are, there are still categories that they all fall into. Galaxies are categorized by shape. The shape of a galaxy provides valuable insight into its age, its development, and its history. The most abundant type of galaxy is an elliptical galaxy. Generally, they are older, calmer galaxies that typically don't have large amounts of new star development. Often, these galaxies are outshined by younger, brighter galaxies. The next type of galaxy is an irregular galaxy. They do not have a defined shape. They are normally galaxies in the process of a collision or are settling from a collision. Because of the irregular shapes and high amounts of activity, the nebula are often very active, producing many stars. If you want to know more about nebula, I made a video on the topic, and you can find the link to that in the top right corner. Spiral galaxies are some of the most spectacular. In fact, our own galaxy is a spiral galaxy. These galaxies are characterized by their long sweeping arms that normally have nebula within them. Spiral galaxies have some of the most active star-forming nebula themselves, leading them to be some of the brightest galaxies in the universe. When scientists Vera Rubin, Kent Ford, and Ken Freeman studied the behavior of spiraling galaxies, they were able to calculate that galaxies don't have enough mass to stay together. They found that the outer edges of a galaxy should fly away at the speeds they are traveling. There just simply isn't enough mass in a galaxy to stay together. This problem led to the inference that there is a missing type of matter that must be present in galaxies. Originally known as missing mass, it is now called dark matter. Dark matter makes up the majority of the mass in a galaxy. In fact, the average galaxy is 5 parts dark matter and 1 part baryonic matter. Dark matter has never been directly observed. We've only observed it through the study of mass in galaxies and from gravitational lensing of light. Dark matter isn't the only mystery astronomers face when studying galaxies. When observing distant galaxies, astronomers notice the majority of galaxies are redshifted. This redshift comes from the Doppler effect, where objects moving away get redshifted from the stretching of the light's wavelength. Inversely, light is blue shifted when it is accelerating towards the observer. Astronomers notice that most galaxies are redshifted. This means that they are all accelerating away from us at incredible speeds. This can only mean one thing, that the universe is expanding. Physicists do not understand why the universe is expanding. What we do know is that more distant objects are receding away from us faster. The rate of expansion is known as the Hubble Constant. It's 47,300 miles per million light years of distance. This leads to an interesting thought. What will distant future generations see when they look at the sky? Eventually, all other galaxies will either collide with us or recede away from us past the point in which we can observe them. A future generation, or any future intelligent species, will only see their own galaxy and will never have a true understanding of what it was like to live during our time. They'll never have a true concept of the scale of the universe, and they'll never understand the beauty of our time. A lot of times we forget to appreciate what a time we live in, not only in a societal sense, but also in an astronomical sense.